Here we go with our beautiful, nice white background now. So it's a little different. So it's just something new today. So what?
It is kind of a whiteboard.
It is a whiteboard, exactly. All right, let's take a look. This is called parallel lines of proportional parts. So what we have here, to tell you the truth, I don't. The book has these A, B, and C things right here. I do this a little different, just to make it a little easier for us. I'm going to put different letters here. I'll put a red right here. Let's make this A, and make this B, make this C, make this D. This would be a lot better than saying AB and AC and AD and all that. It just makes it look a little easier. So what is the A? The A goes from here to here. You see it? And from here to here is B, that's C, and that's D. All right. So what this theorem basically says is if a line's parallel to one side of a triangle, intersects the other two sides, which this does, doesn't it? It's parallel to the third side, it intersects the two other sides of the triangle. It says it divides the segments into proportional lengths. What does that mean? That means this, and we don't know this just yet. Now, first of all, are the two triangles similar? Is this smaller triangle similar to the whole big triangle? Yes, it is, because these are parallel lines. That means this angle and this angle will be equal because they're corresponding angles, right? It means this angle and this angle would equal. They're corresponding angles. So I've got two angles of one triangle, the little one, equaling two angles of the big triangle, the whole big thing. Would you agree? So they are similar to each other. And you're right, it's angle-angle similarity. So we know that they are similar to each other. So we also know some things are true. I could compare A to A plus B, couldn't I? Right? Because I'm going this side of the small triangle to the same side of the big triangle, right? So I could go A to A plus B. Then what I would do over here, I'd go C to what? C plus D. You with me on that? And if I put a E and an F in there, E and an F in there, I could go E to F. But what this theorem says I can do is this. I can compare A to B. Even though B isn't one of my sides of my triangle, is it? It's not a side of my triangle. Would you agree? It's a part of a side of a triangle, but it's not an entire side of a triangle. But I can compare A to B. And so what do you think that would equal over here? If I go A to B, then I come over here on this opposite side, and I can compare what? C to D. All right? So how does that work? So you would rather I put the A, B, C, D
Yeah, just
like we did
because that's how
before?
the book does it.
Really?
For the question.
Nah.
No, 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 I don't care about the lettering. I was just saying the actual concept of.
Oh, yeah, because I kind of like the lowercase letters here. Well, watch. Look what we're doing. I'll put arrows. Maybe that'll help you. If I can take this segment and compare it to this segment. And then I can take this segment and I can compare it to this segment. Or I could go the other way around too, couldn't I? I could go B to A equals D to C. Here's the way I couldn't do it. I cannot go A to D, right, equals C to B. I can't go diagonally like that. Let me just show you. I'll show you. It's a good question. It's a good question. So let's take a look. Watch right here. Here's the question I'm asking you. Can you go A to D equals C to B? Well, watch this. If I cross multiply, what do I get? I get AD equals what? BC. Do you agree? All right. So what if I did it this way? I'm going to put this in a box because you can't do this right, right? So watch this. Can I go A to D? What's that? Equal C to B? Some people try to do that. Compare this one to this one. But can you do that? Well, let's cross multiply and see if you can see scale back. That's what A to B. This is going to be what? C to D. That equals this. So these are not the same function. So you can't do it this way. So you can't go diagonal. But you had a question earlier. You said, can you go A to C? And then what? B to D. Can you do it that way? Well, let's see. How can you check? How can you check? Cross multiply, right? Let's see if we're the same thing. So if I cross multiply, I get AD equals what? BC. Is that the same as that? Absolutely. So can you do it like that? Absolutely. You would go A to C, but then you'd have to go what? got arrows going all over the place. Right? And of course, you could always go backwards. Okay, you can go C to A. The only way you can't do it is diagonal. Got it? And that's very helpful. You know what they're going to do here, don't you? They're going to put some numbers in here, and one of them is going to be a variable. You just have to solve a variable, plug it into something like this, cross multiply, get the answer. All right, that's the kind of stuff that makes. Does that make sense? What if, let's do this again, but different. Let's get rid of all this. All this. Oops. Get rid of all this. All this. And that. That. And that. We're almost there. Almost there. Get rid of that junk. Not clean now? Yeah. What if they said this? Let me see how I can say this. Now, before, they told you that the lines were parallel. Let me actually get rid of the parallel lines, too. Right? On the one we just did, they told you that the lines were parallel. By the way, they called that the triangle. Let's write it down. They call the triangle proportionality theorem. Proportionality.
It's a long word.
It is a long word. Proportionality theorem. And what did that say? It said if I had a triangle, parallel lines right here inside that triangle, then you can compare the sides the way we compared them. Correct? Let's do the converse of that. What did the first theorem say? It said if the lines were parallel, then all these sides were in proportion. So what do you think the converse of that's going to be? If what? So if A what? Over B equals C over D, then what do you think is true about these two lines? They got to be parallel to each other. Does that make sense? Okay, so again, right now, we're doing the converse. Right now, we don't know those are parallel to each other, but for some reason, we stuck some numbers in here, all right, and we saw that, yeah, they have the same ratio. A over B is the same thing as C over D. If that's true, then what can I say about this line and this line right here? They have to be what? Parallel. And we've done that converse thing quite a bit before, haven't we? We do it over and over again. We give you a theorem, and then we say, okay, here's the converse of it. So that's pretty helpful. Let me do one more, and we shouldn't have wasted so much time at the beginning. Let me just do this. Have we talked about the mid segment before?
Yeah.
Seems like we have, haven't we? Yeah, let's do this. What we're going to do, let me do this real quick, okay? I'm running out of time. So look at, watch this thing right here. This thing right here, let's find the, I'll just keep it all in blue. Here's the midpoint. Watch, everybody watching? That's the midpoint right there of this side. Let's take this side over here. I could take either one of these other two sides, and that would be the midpoint right here. What do you think happens if I connect those two midpoints of that side right there? Look at that. Not just any old line. What do you think? If this is a midpoint and this is a midpoint right there, what do you think is true about these two lines? They are parallel to each other. If they're parallel to each other, what's true about the two triangles? The little triangle on top and the whole big triangle. They're similar to each other. If they're similar to each other, you could do the whole scale factor. But what is the scale factor of these two sides of A to B? Quick. What's the scale factor of A to B? Or C to D? They have the same scale factor because they're... Look, this is equal to this. Come on. This is equal to this. What's the scale factor? What's the actual number scale factor of A to B? Come on. The actual number. I want a number. 1. It's 1 to 1. Because look, if this side and this side are exactly the same, look, if this is 5, then what's this side? 5. What's 5 over 5? It's equal to 1, isn't it? So the scale factor in this situation will always be 1 to 1 between those two segments. Okay? All right. Let's do another thing, and then I think we'll pretty much have taught this lesson. If the bell rings, just hang on for a minute, okay? I'll give you a pass if you need it. If you had the mid segment. By the way, that number, that thing in between there was a mid-segment, okay? Watch this. Bang, bang, right here. Now, it is a lot of lines, but watch this. These three lines are parallel to each other. And look what we have here. We've got some segments, don't we? Let's call that little segment A and B. Call this C and D. This is very, very close to what we did with the triangle and having the parallel line inside that triangle. Because look, kind of looks like a triangle if that kept on going, doesn't it? And it's kind of the same deal. So let's take a look. What do you think my proportions are here? If these are parallel lines, three parallel lines cut by these two transversals, what do you think? I could probably go what? A over B equals C over D. Good. What's another way do you think I could do this? I could set this up. I could say A over what? No, I can't go over A over D. Remember we said you can't go diagonally. What do you think? A over C would equal what? B over D. Everybody see that? Because how do I know that they're the same? Because if I cross multiply, they become the same exact proportion, don't they? Do you see that? So AD, or the same product, whatever you want to call it, equals BC. What can you not do? You cannot do what? A to, no, not horizontal, diagonally. You can't go A to what? D and C to B. You can't do that. You can go this way, right? Back and forth this way. Or you could do this way. All right? You can't go diagonal. Because they got to have something in common. Look at this one. We'll call this the top left one and this the bottom left one. So what do they have in common? They're both on the left. What about the top right one and the bottom right one? They're both on the right. What about from the A to C? This is top left, this is top right. They're both on the top. You see it? So they have something in common. Let me give you some problems to work on. And then you can go. And it's not a worksheet. I skipped Wednesday because we went 2 days on Monday, so I skipped Wednesday with the worksheet. So this is 10 to 27. Numbers 10 to 27, and it's section 7-4. You can find the page numbers. Just look at 7-4 and look for 10 to 27. You can find the page numbers. Starts at 489. It goes to 491. All right, so there you go.